Okay, so let's go ahead and I'm going to video all the homeworks 1, 2, 3, and 4. I'll do them separately, post those, as well as I'm going to go ahead and post a picture of the answer key for y'all for the homeworks also, okay? So let's start off with homework number 1. I know the homeworks, we did some of them or most of them in class already. So this just might be a review. You may not really want to watch it. You may just want to make sure that you have the right answers. But let's go ahead and let's go back over the homeworks again, especially if you were not in class when we went over them. So question number 1 says here that a beetle sits on the top of a bicycle wheel and flies away just before it's about to be squished, assuming that the wheel turns clockwise. So they actually gave us the word clockwise here, which is a negative direction. I'm going to put negative. And the beetle's angular displacement is 1 pi rad. Remember, 1 pi rad is the same thing as a half of a circle, or, because that's not going to work for us as a number-wise, 3.14 rads, okay? Which corresponds with the arc length. Arc length is the outside edge of the circle around that circumference. So that's going to have a lowercase s as the symbol, 1.2 meters. What is the wheel's radius? Question mark R. So we're looking for the radius. We're going to go ahead and use theta equals S over R. Okay, that's our equation. They gave us theta, which is right here. Let me go ahead and put that. Theta. They gave us S and we're looking for R. I'm going to go ahead and put this into the triangle because I want to just shortcut my algebra. I'm looking for R. R equals S over theta, and that's how I'm going to solve it. S is 1.2, theta is 3.14. Go ahead and do the division. I get an answer of 0.38 meters, but it is in the negative direction, so it's going to be a negative answer. Okay? Let's go ahead and keep looking. Number 2. It says here that Earth's equator radius is approximately, so they gave us the radius over here for Earth. And it rotates 6.28 rads every 24 hours. That's my theta, which makes sense, right? Because 24 hours is one full day, which is day and night, or one full rotation, 360 degrees, which is 6.28 rads. Now, if somebody was floating in outer space and they looked down, what would the angular displacement be, question mark theta, for a person that was standing there for 1 hour instead of 24? So in this case, it's going to be 6.28 divided by 24. And if we divide it by 24, we can find each individual hour of how long that theta is. So that comes out to 0.26 rad. Then it says down here, well, what's the arc length traveled from this person? One more time, arc length is going to be that outside edge, okay, around the circumference. And that's in meters. So we're going to go ahead and put a question mark S. That's what I'm looking for. Now, they gave us, let's look at the equation, theta equals S over R. They gave us R, check. They gave us theta, which is over here, check. We're looking for S. So I need to rearrange this into the triangle. Here it is. Let's go ahead and let's look at it here. S equals theta times R. And our problem here, before we can go any further, is we're going to have to come over here and do step 1. Step 1 is that this is in kilograms, so we need to convert it to, kilometers, and we need to convert it to meters. So King Henry drinks utterly delicious chocolate milk. This is kilo. We need to go to meters. So we're going to move our decimal place to the right. 1, 2, 3 places. So instead of it being 6380, here's the decimal in the back invisible. Let's move it 1, 2, 3 places, and let's add those zeros. So in this case, it's going to be 0.26, multiply it by 638,000,000. And we're going to go ahead and multiply those two numbers so that way we can get our answer. And let me make sure I get that answer correct. So that's 0.26 multiplied by 638,123,4 equals 165,8800. And we are looking for S, which is the arc length, the outside circumference, and that's in meters. Okay. Let's go ahead and come down here to the bottom part. They told you either theta, S, or R is one of those that you're looking for. I'm going to go ahead and just write the equation that we're going to utilize, which is theta equals S over R. And I'm going to go ahead and also plug that into the triangle over here so we can see that when we need to rearrange that. S is on top, then R and theta. Now, they also ask for direction. Remember, if we're moving clockwise, which is going to be to the right, it's a negative value. If we move counterclockwise, which is to the left, that's a positive, P-O-S, positive value. Alrighty, so when we come over here and we look, we do have an S that is a positive, so I'm going to go ahead and put counterclockwise. I have a theta that's positive, counterclockwise. I have an S or arc length that's a negative, so clockwise, and then I have a positive S, counterclockwise. Remember, if the S or the theta doesn't have a positive or a negative, that is one thing that is okay to assume is that it's going counterclockwise. Okay, so if there's no indication, counterclockwise is the correct answer. Let's go ahead and look. Number one, or letter A, we're looking for the theta, so we're going to leave it as S over R. So I'm going to put S over R, or 0.25 over 0.10, and I got 2.5 rad. Letter B, we're looking for the S. Come to the triangle and cover up S. When I do that, I'm going to multiply theta times R. So theta times R, theta is 0.75, R is 8.5. Multiply those two numbers together. You should have got 6.38 meters. Please make sure you have the correct SI units. The next one, letter C. Here is my theta over here. That's what I'm looking for. So we're going to leave the equation alone as is. So S over R. S, which is negative 4.2. R is 0.75. Okay, let's do the division. We're going to get a negative value, which is negative 5.6 rad. The next one, letter D, we're looking for radius. Let's cover it up over here on the triangle. Radius is S over theta. So S over theta. S is going to be 2.6. Theta is 2.36. And I got a number of 1.10 meters. Okay. Pause it when you need to. Just make sure definitely that you have the steps correct and you have the correct answers. Let's turn this page. Now on this side we were using a protractor, and again, like I've mentioned already multiple times, we're going to have to use a protractor on the test. That's a guarantee. But let me go ahead and practice right now with the protractor to make sure that we're all on the same page. First step is when you're doing the test, you're probably going to notice that this arrow just may not be long enough for you, this line, for you to find it. So my suggestion is to go ahead and find that line that's lined up over there and extend it. Alrighty, then I like to have either the X or the Y axis nice and extended also, just so that way. So I know that we always start at 0 degrees and we work our way counterclockwise to 90, 180, right? And then we go to 270. And then back to 360. Alrighty. So if from this point to here is 180, then if I find out this little piece of a section right here, what that theta is, I can add that to 180. How am I going to do this? I'm going to go ahead and turn my protractor upside down. I'm going to line up my x-axis and my y-axis. Once I get them lined up, I can come over here and look. This is 0, 10. Right here, right at about the, what is that? 15. Oops, sorry. Comes over here, 16, almost 16 and a half. But it's, I'm getting right now 16. When I did my answer key, I was 17. So remember what I said. On the answer key, it has it at 17 degrees. Right now, I found out that it was 16 degrees. Please take your time. I'm okay with you being 1 degree over or 1 degree under. Let's add those together. I got a number of like 197 or 196 or 198 degrees. All of those are good. Good valid answers. Okay, now the next part here that we need to look at is, let's go ahead and convert this to a radian. Okay, so to convert that to a radian, hopefully you take a look at your formula chart, and here it is right here. I've got a degree and I want to convert it to radians. Remember what my suggestion was. Grab that formula chart and go ahead and start looking at it. So to do that, I'm going to get the degrees, which is 197, multiply it by pi, and divide by 180. That's how I'm going to solve this. So 197 times 3.14 equals, divide by 180, you should have got something like 3.44 rad. Okay, let's do this again. My suggestion is for you to go ahead and get this arrow. Extend it out. Again, me personally, I like to have either that X or that Y, one of them to be extended as a reference point. I know if I start here and move this way, I'm 180 degrees. So I need to find out what this section is. I'm going to come over here with my protractor, line everything up. All right, so 10, 20, 30, 40, 50, 5, 56. So right now I got 56 degrees. On the answer key, they have 57 degrees. Okay, either way would be great. So if the answer key says 57 degrees and you added 57 plus 180, perfect. If you found it to be 56 degrees plus 180, again, that counts perfectly good. That's a great answer. So the answer key says it is 57 plus 180. So 237 degrees should be the answer. Let me make sure I didn't screw that up. 57 plus 180 is 237. Let's come over here and convert this to radian. So 237 multiplied by pi equals, divide by 180 equals, I got 4.13 rad. That's my answer. Okay. So double check. Hopefully Let me see, make sure I didn't screw this up. 180 plus 57 equals 237 times pi equals divide by 180 equals 4.13 is what I got. Okay. Let's go ahead and finish up. We got 2 more questions here. It says here, when riding a carousel that is rotating clockwise, what does that mean? That is a positive, I'm so sorry, that is a negative direction, clockwise. A child travels through an arc length, which is S, of 11.5 meters. If the child's angular displacement, theta, 2.88 rads, well, what is the radius? Alrighty, so theta equals S over R, okay, is my equation. I'm looking for R. I'm going to go ahead and plug this into the triangle. S is on top, looking for R. R equals S over theta. S is 11.5, theta is 2.88. Do the division. Hopefully you got something like 3.99 meters, or you might have rounded it up to 4 meters. Either way, that's a great answer. Okay. Next one. It says over here, the average angular speed of a fly moving through a circle is, angular speed is the omega sign, which looks like a W. 7 rads per second. How long, question mark T, does it take for the fly to move through a 2.3 rad? What is that? That is the theta. Okay, 2.3 is a theta. Show your work. Well, we're going to go ahead and use here the angular speed, which is omega equals theta over time. But we're looking for how long? We're looking for the time. Theta is at the top, time is at the bottom, and then omega. Let's look for T. T equals, cover it up, theta over omega. Theta is 2.3, omega is 7. You should have got an answer of 0.33 seconds. Okay. 0.33 seconds. And up here they said clockwise. Radius is not going to be a negative value if you were wondering. Okay. Radius is that distance from the center outward, which is only half that circle of the diameter. It's not a negative. S could be negative. Theta could be negative. But radius is not a negative value. Other than that, we went through all the answers. I know we did them in class, but just in case, here they are again for everyone. Alrighty.